So this is the week 10 chemistry AMS quiz. It's almost the same, it's all the same as the periodic material. It's really easy. So it's mostly topic 1. So which of the following mixtures are best separated in using simple distillation? Simple distillation is the one where you have to evaporate this liquid and condense it. If you watched my video explaining the topics, we know that most aqueous solutions, like sodium chloride was the example they gave us in the paper, and sugar alcohol solution are separated by simple distillation. Sugar, salt, and water, no, because you're still gonna have salt and sugar in the same thing. Oil and water, no, because they're two immiscible liquids that you can separate by separatory funnel. Water alcohol solution, we cannot use simple distillation because they have really close boiling points. Which brings us to our next question. Which ones do you need to use fractional distillation on? Water and alcohol solution, because they have really close boiling points. Sodium chloride aqueous? No, because we use simple distillation for that. Why need the fractional? It's just gonna waste more time. Like this, again, you cannot do this with any type of distillation, and you cannot do this with any type of distillation. This is separatory funnel. Now, next question. A mixture of miscible liquids have close boiling points and separated into their components. Close boiling points is your keyword. Once you see close boiling points, immediately fractional distillation. You don't even look at the rest of the options. It can never be any of them when you see the word close boiling points. Only fractional distillation. Okay. Now this question, I explained it in the video. I'm going to re-explain it. So when you have amino acids, they're clear, they're colorless, and they can be analyzed by chromatography. But how will you make them have color? So we know chlorophyll is the green pigment in plants that gives it its green color. The amino acids... Oh wait, here they didn't mention chlorophyll. Anyways, for amino acids, when you want to bring out their color, we use UV radiations to reveal the spots. You don't use IR, no. You use UV radiations, which is sun. And you have to spray them with a locating agent that reacts differently with the components of the mixture. Purple potassium permanganate, not gonna do anything for this amino acids. Paper chromatography IR radiation, no, not IR, UV. Spraying the spots with special dyes, no, there's no special dyes. We have locating agents. Now next question. Okay, so what's a compound? We know a compound is anything or any two elements that are bonded together chemically combined and cannot be separated by physical methods. Okay, so let's read. Wood is a compound. No. Wood is wood. Wood isn't chemically combined by anything. It's just wood. It's a collection of at least two or more substances that are not chemically combined. No, they are chemically combined, so this is wrong. That cannot be split by chemical means. If this word was physical, then this would be right. But compounds can be split, can be split by chemical means, cannot be split by physical means though. It's made of two or more elements that are chemically combined together. Yes, they are chemically combined, and it is two or more. It has to be two or more. Calcium carbonate is a compound? Yes. We know this because, first of all, it was an example given in our topics, and second, it's calcium carbonate, CaCO3. This is a compound. It's not one element. It's more than one element, and it's not a mixture because they're chemically combined. They're in one reaction or one equation or whatever. Now moving on. Now we have which of the following can be separated by filtration. So filtration means insoluble solids from liquids. Filtration is when you're using a conical flask, thing like this, the filter thing, and the filter paper. It's when you have solid and water, or when you have two insoluble solids and from liquids. Sand and salt, they're two solids, so you have no liquid, so you can't use filtration. Oil and water, we said, two liquids, you need to use the separatory funnel. Or if they have close boiling points, fractional distillation. Homogeneous, no, it's heterogeneous. Heterogeneous mixtures. Yes, homogeneous, no. Examples of mixtures contain steel and paper, because steel is something, like it's a metal, and paper is something. It's not even, I don't even know, like, these were the only two options that made sense. Like, they're two solids, and one is, like, you could distinctly see them when you're looking at them. This question is pretty much just common logic and sense. Heat ethanol, be careful, ethanol is volatile, and you can never so never heat on or never get close to direct, I'm gonna even write it in red because it's really important, direct flame. Never. It's a health hazard, you never do it. Bunsen burner, direct flame. Wrong. Bunsen burner, direct flame. Here they use an electric heater, but there's a direct flame over here, so wrong. Here, there's an electric heater. You have ethanol and water. You have a beaker. You have a stirring rod. No direct flame. It's the only one that you can use. Okay. Scientists found a chemical with no tag on its label. To determine its nature, he should measure the melting point and the boiling point, because we know that for same elements. You have the same boiling and melting points. That's it. At any temperature, when it is neutral, we have OH must equal to the concentration of H. When you see the word neutral, means equal. If you see the word basic, it's like this, acidic, like this. But it depends, like which side is OH on which side is H on. Now, these types of questions, to find pH, when they give you some weird number like 0.32 or whatever, you're gonna do pH equal negative log of your hydrogen plus concentration. Now, a little trick. When you see a number like this, that's just 10 to the power of negative 2, you take the power without the sign and you put it as your answer. So 10 power negative 5, pH would be 5. 10 power negative 8, pH would be 8. 10 power negative 1, pH would be 1. Like, just take this rule, memorize it. Easiest way to solve it in the exam when you see a number like this. I'm going to show you this in another question. It has its own question. Equivalence point is the same as neutral, almost saying, so H will equal OH. Okay, how to obtain salt crystals? By crystallization, because they told us following steps of crystallization. Now here they added 3 things that we don't need to use. Now memorize these steps. You always will heat the solution on the Bunsen burner until most of it evaporates, not all. Then you're gonna put it in a water bath. Then you're gonna heat it until the remaining solvent evaporates completely. Okay? Then you're gonna leave the crystals to dry overnight. That's it. We don't need a fractionating column. Crystals as insoluble solids from the solution, that would mean to filter them, which we don't filter them, so no. Using a separatory funnel. Separatory funnel is only when you have 2 liquids that have different densities. So no. So these three, we just erase them and we use these in order. Okay, now look, this is paper chromatography. I'm almost 100% sure they're gonna get a question about this in their periodic tomorrow. That is least soluble and it has the most affinity. Affinity means sticking power, by the way. Whenever you see the word least soluble, most affinity, it's the one closest to your baseline. If you see most soluble and the least affinity, means the one furthest from your baseline. Just take these as keywords. Okay? So the one with the least soluble and most affinity, which is closest to our baseline, is C. Now, find the RF value for component A. This component, they want the RF value. How do we find the RF value? So what you do is really simple, really. You're just going to take this distance, and you're going to take total distance, and you're going to divide this by this. 10 divided by 12 equals 0.83, I think, or is it 0.80? Yeah, 0.83 to two significant figures. That's it. Now this, memorize, but I'm gonna help like a bit, right? Let's solve the ones we can see. MgO, if it's not one of the ones I told you to memorize in my video, and if it's like I told you, memorize all the amphoteric ones and all the neutral ones, and the rest you could deduce them. Basic means it's most likely a metal oxide. Mg is a metal, so this is basic. CO2 is not a metal, and it's not one of our exceptions, so it's acidic. CuO, metal, basic. N2O, one of our exceptions, it's neutral. CO, one of our exceptions, it's neutral. ZNO, one of our exceptions, it's amphoteric. SO2, not an exception, and it's not a metallic metal oxide, so it's acidic. Al2O3, one of our exceptions, amphoteric. And last one, CaO, is a metal oxide, so it is basic. I made a whole video explaining this, guys. It's really like easy or helpful if you watch it. Okay, how many questions left though? Okay, so it's still 20 questions. Okay. So we have a student. They want to find the concentration of hydrogen ions and hydroxide ions in a sample of a 400 m strong acid. So since it's an acid, and they gave you the acid's whatever, the equation. Now look, if the acid's equation is H2, A is whatever. A isn't an element, A is just random. It means that this acid produces 2 H plus molecules plus A. Whatever A's sign is. A is most likely minus. Since it's 2 H plus, and we have our M is 0.400 for this. So when you have 2H, we know that H concentration is always equal to the solution. But since here you have 2H, which means you doubled H, you're going to take this 0.400 times 2. That's it. 0.800. That's how you get it. Now, using our H value, of course, we're going to use, which is concentration of OH equals concentration, equals 10 power negative 14 over concentration of OH. Of H, sorry. Oh my gosh. H plus here is OH minus here. So we're gonna replace this here by 0.8. Solve it on your calculator. I'm gonna really quickly solve it to make sure. 10 power negative 14 over I typed it wrong, wait. Over 0.8, or is it 0.8? And you're gonna get 1.25 times 10 power negative 14. And that's it. Now let's move on. Here again, let's solve. You have hydrogen ions in a 0.600 m. You need to find, hydrogen ions in KOH. concentration of OH, or wait, sorry, concentration of H plus equals 10 power negative 14 over concentration of OH minus. So since this is your concentration of OH minus, then what are we gonna do? 10 power negative 14 over 0.06. Oh, by the way, here guys, my answer was wrong because I mistyped this in my calculator. It's 1.7 times 10 power negative 13. So yeah, that's what you're gonna get. It's equal to 1. You're gonna get 1.67. They want to two significant figures, so round it up to 1.7 times 10 power negative 13. That's it. See? 1.7 times 10 power negative 13. Okay. This question is really easy. They want you to find the pH of a solution having hydrochloric acid. Dissolve 0.08 mole of this acid into 50 milliliter volumetric flask. Now we need to use our equations from last year, which is N equals CV. So since N equals CV, here we have the N and we have the V. But we have to make the V into liters, not milliliters. So 0.08 equals, we need to find C, and V is 250 times 10 power negative 3. So you're gonna do C equals 0.08 divide 250 times 10 power negative 3. You're gonna get 0.32. Now you do the formula pH equals negative log of concentration of H plus ions. Since it's 0.32, negative log of 0.32. You're gonna get a long number to 3 decimal places. This is your answer. Now, you know that we use a separatory funnel, like I've been saying this whole time, from liquids that have two distinct layers, like oil and water. Oil is gonna float on top of water. You're gonna see a clear distinction line here, which means water is gonna filter out first because it's more dense. Now, last question. Okay, at point X, what can you see? At point X, this is a titration curve. So at point H, the number of moles of H plus added is equal to the moles of OH present. Why? Because look, X, over here you go, it is 7. We know 7 is neutral. 7 means that OH minus equals H plus, since it's neutral. So if the number of moles of OH present, and the pH will change drastically. At point X, the number of moles of H plus added is equal to the number of moles of OH present, and the pH will change drastically. Guys, I can't read anymore. Bye. I hope you understood everything. Have a nice day. Bye.